So, okay, very good evening to you, Prof. Deepa Chari, and all of you participants this evening. Let me first start by introducing Prof. Deepa Chari. She's a faculty member at the Homi Bhabha Center for Science Education of the Tata Institute of Fundamental Research located in Mumbai. Her research interests are physics identity, physics education, and diversity research to enhance representation of minority groups in physics. Deepa is also a coordinator of Vigyan Pratibha program, aimed at teacher capacity building and student nurture program at a high school level. Through this program, she has interacted with science and mathematics teachers of over 500 schools to disseminate Vigyan Pratibha learning resources. At the Homi Bhabha Center for Science Education, Deepa is also involved in teaching graduate courses on STEM pedagogy. Also, she contributes to other TIFR and HPCSC, which is the Homi Bhabha Center for Science Education, institutional programs like Vigyan Vidushi, targeted at the postgraduate level students, and NIUS, which is the National Initiative on Undergraduate Students at the BSc level students. Deepa has earned a PhD in physics from the Dublin Technological University, Ireland. Before HPCSC, she worked with the American Physical Society Bridge to Doctorate program to improve PhD department's policies to support physics graduate students. She was also a postdoctoral fellow at the Physics Department of Kansas State University and Florida International University in the US. So it's a pleasure to have you with us today and welcome you to start the deliberations. Thank you very much for making the time to speak to us today.
So good evening, everyone, and welcome to the NEP Orientation and Sensitization Program organized by the Malviya Mission Teacher Training Program at Ayuka. And so at HBCSE, which is Homi Bhabha Center for Science Education, I primarily work in physics education and with a focus of gender in physics. But my larger work domain has been interacting with physics teachers and science teachers, mathematics teachers in general at all levels, starting from school to PhD and also at various professional junctures with professional bodies which are involved in physics community building at various levels. So as I'm aware that you are nearly a week into this TPD program and you have already discussed various themes associated with recent educational policies and its implementation. But I think what I could gather is most of the people in the audience are related to higher education institution to a great extent. So my talk also tries to bring more ideas about equity and inclusion theme, but in the higher education domain. And you kind of have already heard some ideas associated with diversity and inclusive education theme in context with students with different or students with different abilities in previous talk by Professor Mehrotra. So my focus has been lies within the inclusion and diversity domain, particularly on gender. All right, so think one of the prime recommendation of our national education policy is making quality higher education opportunities available to all individuals. And for this, the policy envisions that we should ensure equitable access to quality education to all students, and with a special emphasis on socioeconomically disadvantaged groups. So if we think in terms of gender, the policies target to increase representation of all genders, which are disciplinary underrepresented, with a special focus on how perspectives such as, let us say, socioeconomic conditions, caste, geographics, or language, or any other barriers, which may also play a hindrance to this inclusion effort. And in fact, as many studies in India and outside have shown that much of these factors, in fact, intersect with the identity of gender and results into the barrier in higher education opportunities. Not just that, but they also stand as a barrier to retention of these marginalized communities, and overall as a barrier for representation of genders at higher level positions, particularly in academia. So an emphasis on socioeconomically disadvantaged groups lies well within the principle that we are not just winning all women experiences together for the sake of thinking about like how gender can be like how gender can be made more lucrative in terms of diversity and inclusion. But we are very much, or the policy itself is very much aware that there are differential factors that should be taken into account in considering how gender, along with the other intersectionalities, may play in diversity and inclusion context. So before we make any further discussion, and I would like to chip in once in a while, like what you think about all of these factors. So feel free to unmute and talk. But let me just clarify that though I am speaking or I have picked up women or talk about women in specifically in the gender lens, gender sensitization idea as a whole is not restricted to women alone, and it expects the complex gender identities which often go beyond binary nature, and it supports all gender representation at higher education. So again, with my background in physics and some prior work or my interaction with physics communities for a while, I'm bringing most of the examples as cases or stories or anecdotal evidences from physics discipline. But the central idea about diversity and inclusion holds good for more or less many other underrepresented disciplines. So I hope, think I made my stand clear about like why I have chosen to talk about women lens in particularly in terms of gender diversity and in terms of diversity and inclusion. However, as a policy for diversity and inclusion, gender is not the only diversity and inclusion that is thought, and I hope others can also comment, or others might have also given their thoughts about how operationalization of these things within national education policy has happened so far. So to gather some more sense about what is there written in terms of gender in the national education policy. Again, I have categorized all of this in 3 different sets, and we will talk about these sets on and often, but these these categories are just made for sake of easiness. So otherwise there is no strategy or no particular agenda for it. So the first sector or the first set is service, environment, and culture. And what these attempts or what mentions about gender in national education policy about these are it talks about like the policy talks about how curricula, which involves both textbook as well as enacted curriculum, is what it recommends in terms of building sensitivity about gender. The policy also talks about environment, where the environment should be such that all genders are felt respectable and experience a richer and conducive environment for science and mathematics learning. And in terms of access, it talks about how one ensures that the students or the applicant at respective levels have enough information for and enough approaches for accessing the type of education within science and engineering domain that they would like to and the education policy through institutional and support structures make it available. So I think in this, I have chosen or I have kept this section separate because some of these things are said in school context in national education policy, but it is also mentioned that much of the knowledge that about gender inclusion at school education actually directly contributes to the initiatives that are being taken at higher education institutions. So conduciveness of the environment for inclusion is true for all level of education, and the informed choices can be influenced by what we learn from making our high school environment or school level environment more inclusive at the first place for science and mathematics learners. The NEP also ideates the gender with respect to access by means of offering financial assistance to women students in higher education institutes, and particularly in teacher training programs, so that the long-term effects of our budding, we can see the long-term effects on our budding generations via our future educators. So more investments are done on specific programs like B.Ed and within that to science and mathematics teachers or those B.Ed students who are opting for science and maths as an optional course, such that they not only are they are seen as an ambassador, or they are seen as somebody who would make an impact even in a longer in the future generation. And gender sensitivity overall is seen that should be built in the pedagogy, such that if there are some specific or different needs for different genders, those are taken care, but of course without an explicit mention. Now, what does this mean? That let us say if you feel or it would be wrong practice or a stand which is not advisable is to see how different genders perform in a particular test, and also avoid some references such as how boys and girls do, which in relation to a specific test. However, knowing this information implicitly might help teachers or educators to take particular pedagogical stance when and as needed. So I think many of you are dealing with students in laboratories at undergraduate level or at college level on day-to-day basis. So another pedagogic stand that operationalization of national education policy in terms of gender recommends is if you are if you are in a lab setting, then probably it is advisable to ensure that all the group members have an equitable participation opportunities, particularly when it comes to handling expensive laboratory devices and alignment tasks. Again, these differences are seen more in BSc level classes, when particularly you have a heterogeneous population group, and students sometimes would be hesitant to or tend to pass on the roles, particularly when it comes to alignment of heavy instrument or lasers or spectrometers, because they think that the data that the group is generating is then a responsibility of a solo person, and often we don't, or you don't want to be that solo person in the group. So the teacher training program, though when mentions about pedagogical stance, not much description about how this stance would look like in different disciplines appears actually in the education policy, but it is an implicit knowledge that as a community of physics teachers, chemistry teachers, or science teachers, maths teachers, we should bring and help in writing the operational goals for national education policy. And lastly, but I don't think it is the least, gender is seen more in a holistic aspect, which should not just be dealt at an individual level. So many things that you do with respect to gender lens for diversity and inclusion may stand out as an individual level efforts or efforts done for a particular student, for a particular girl student taking education at undergraduate or UG or PG level. But it is also important to see this problem holistically and how institution as a whole can bring awareness about how diversity in terms of gender can be made more meaningful for that institution and also for science. So just as an example, there are several national level statistics that we see which brings clarity and key points to address the issue at policy level. But it is also recommended equally that the gender related information for faculty, for student ratio should be updated quite often on our website. So this may look like very much as a technical task of updating admission stat or like faculty profile or student teacher ratio in terms of gender. But these all help the nation as well as policymakers to make decisions about like how a good retention policy for a particular institution, for a particular discipline would look like, and both at the institutional level as well as at the larger or at a policy level. And many of these also stand as a point for how people can or you as a teacher can contribute holistically in this process. So what I would do in next hour or so is I'll bring you through many different examples about or many different cases or anecdotes about why one should think more carefully about gender in terms of diversity and inclusion. And sorry for my long introduction, but we keep touching these points again and again throughout this session. And as a takeaway, I would like all of you to think about maybe one or two things that you all felt were useful in terms of gender sensitization at your own institution or at your individual level or at any other intrapersonal level that you are dealing with students at this stage at your institution or at your university. So I think I would like to also quote a few important people who have contributed in bringing these ideas much at a profound level at national and nationally as well as internationally. So obviously the first quote without mention is of Professor Rohini Godbole, and she's an eminent women physicist and a Padma Shri award winner, and she says that the meaning of gender diversity or like what is the true meaning of gender diversity is making physics or science ecosystem diverse, not just because it is meaningful or it is beneficial for women, but it is also for the science itself. Now, what does this means is the diversity, what we are thinking in physics is A for all, and it is not just for women or by women, but making the science ecosystem gender diverse is beneficial for all because it increases the efficacy of scientific process. It provides dimensions to ensure how all different group of people contributing to it think about it. And last but very much relevant, it is also to understand that the issues that we choose in science to discuss are often influenced by what is our cultural, what is our race ethnic background, or what is our gender background. So any kind of diversity does bring new ideas, but more importantly, and a biggest asset of diversity in any discipline is it avoids missing out of those ideas in science which otherwise couldn't have talked or discussed or even brought on table just because they are experienced by a far few people within that discipline. So with this, I think I have kind of convinced why gender diversity should not be thought as a mission. And I would like to bring this up again because I see that most of the listener of my talk today may not directly associate with the gender that you are working, that you probably are looking forward for making the discipline more inclusive. But your contribution is not seen more in a charity mode, but it is for uplifting the science or scientific process as a whole. Just to like bring some national level stat to make these ideas more clear, AISHI, which is the All India survey for higher education, and there are more reports in 23, 24, but this is the latest I could grab all the numbers. So the AISHI report suggests that undergraduate level percentage population of women in science stream is around 51. For PG, which is postgraduate level, it is around 61.2. And for PhD level programs within science, the percentage of women is around 62. Now, when you see these numbers, you are clearly thinking about, I mean, we are doing pretty okay because it is almost 50%, but see the numbers more carefully. A, this is representing all science discipline and not necessarily the discipline which may not be as exactly mimicking or exactly copying the number. For instance, physics is largely under-dominated by women. Moreover, if you pay closer attention, you would observe that there is some sort of disproportionality even at a larger extent. And if you go beyond PhD in disciplines, particularly like physics, you would see the positions held by women PhD holders in academia, in governance bodies of institutes, and in award disseminating bodies, and leadership overall in science discipline has a great void in terms of all genders. And while your mind kind of starts thinking that these numbers look great and we are doing okay, a counter example, as you could see, I don't need more explanation for this. This is a picture taken by like 3 or 4 years ago, and it represents a head of all national level science institutes who joined for a picture, and this itself is a self-explanatory to show how the leaky pipeline phenomena exists still very prominently as you go up in the leadership or up in the governance bodies representation of all genders, particularly in the domains like physics and mathematics. So when we talk about gender diversity and inclusion, number is definitely a concern, but beyond that, how these all disproportionalities are very much pronounced in certain areas or in certain positions or in certain disciplines is something that I feel is an equally important challenge that we as an educator or we as as a as people who worry about like how the science would look like in couple years down the line in our own nation should really start thinking more carefully about. I think our purpose today in the sensitization is to go a little bit deeper in along with many examples to see why this problem is relevant in our own context and also theoretically. So so sorry if you feel it is going back and forth between some theoretical examples, some literature, and also some data evidences. But the root of gender underrepresentation also lies in diverse dimensions, and that is why we keep coming to topics like cultural practice, gender in education, and also deal with policy as well as individual efforts uh, in that order. So what I would like to do in next few minutes or so is to talk more about some of these aspects, particularly because for a long time in history, who can contribute to physics or what the problem of this also lies very much in the cultural practice of society that we live in and perception of science as a savior and then who can be that savior. Similarly, with more formal institutional structures like uh, institutes and departments and universities, how this culture percolates from our society to the department is something interesting, and that, in my opinion, also adds a little bit to this problem of why we should think more carefully about gender. And even on a larger spectrum, some systematic issues may keep coming about hiring policies, about admissions, which clearly indicate that why this gap cannot be resolved. So, in nutshell, this problem is not cannot be understood by like a single prong, and we need to find various examples which can help us keep informed about why ultimately we should worry much about gender underrepresentation and how we can mitigate or how we can make institutional efforts as well as personal efforts towards it. Lastly, but not least, it is also not like the problem doesn't stop at level of bringing everybody into the discipline or into the program that they would like to join in, but it also lies in retaining them throughout. So you would see another term called enculturation, which is something about like, how you feel more adapted or how you feel more fitting in that within that culture smoothly rather than keeping science or rather than keeping any particular discipline just as an alien enterprise for the student. So it is not just the problem of bringing students in an environment where they feel more adaptable, but it is also ensuring that they feel like staying there, they feel more enculturated, and then they would like to continue and thrive within those systems. So, just to re-emphasize again, I would say that gender diversity and inclusion is not an overnight skill or maybe just a one training job, or not even just one, maybe one person's thing or initiative. But what we should think about is, or we should continuously reflect on this issue. And I would say that you, as an individual, still will be able to make an impact at your own level, and we will just see how probably that can be done. Now, I would like to take a 30-second break and want to do this quick activity with all of you. So this is a routine activity that I do with our undergraduate students when they join for 3-week or 4-week research program at HBCSC. And I mean, in one of the informal discussion, I do ask them to think about the work of one scientist whose work has impressed them. And I think, as you could guess, my next prompt after some time is think about the work of female scientists whose work has impressed you. So, I mean, I don't want you to take up the test, but I would like all of you to think about Before this prompt, what do you think the responses of all were? I mean, can you guess some names they might have come up with? I didn't give any prompt about country, about any particular discipline, and it was very much open-ended question about thinking of one scientist whose work has impressed, but they have to discuss that work. So it definitely goes beyond the name and talking about the work that the person has contributed into. So I think if you have made guesses, let me show you how this looks like. So you could see, I mean, I don't need to say much, but without the prompt, as you could see, most of the observations, again, students particularly often mix the popularity of scientists when you say that the work that has impressed them, and so you would see only the selection is very typical. But if there is no prompt about thinking about the name of scientist, which is gender specific, unfortunately, you would see that not many names of women scientists are naturally occurring in within this typical choice. Now, I haven't made up this data, but this is something, a routine activity. I have been doing it for years, and I don't see much change happening in it. You would also see a pattern in terms of the names that they write when you ask them to write about one women female scientist whose work has impressed them, which is again self-explanatory because oftentimes the resources or the things that are available to them has very few mentions of women, female, or women scientists. Now, this was not specific to any discipline, but I do see that Rosalind Franklin, Marie Curie, and a few more, I think only I mean, neither, okay, only most of them still are either from physics or chemistry and not beyond that. But you could see the section or the selection within the typicality also reduces um, uh, to quite a succinct set of female scientists that the students are thinking about. Now, I'm not sure whether it is a true response of the question that whether their work has impressed them. But I think it is more about the knowledge body of the work of female scientists that is known to them and that they are exposed to. So I think now where this all where this all is heading overall. So I hope all of you are following me with this thought. So I would like to bring here now why this might be happening. So think for a moment about the structures or the pockets that they are exposed to, and think that, see, the scientists are very much part of society, right? And it is not just the student response. Let's see, if we have taken this test a couple of, I mean, even now, our responses may not be like an anomaly to the data that I had shown. And why this has happened? Because again, like, we are very much representation of the society that we live in, right? So we draw a lot from the community that we live in, and underrepresentation in physics, therefore, in my opinion, is not just a problem of the discipline itself, but it has a deeper connect with the society. So what again, I mean, bringing the quote of Professor Rohini Godbole, what she mentions is there doesn't seem to be a general perception that women lack intellectual skills required for a higher career in physics. Instead, the problems seem to arise more from societal perception of appropriate role for women. Now, think more about this. So what it says is what we think physics is, who can contribute to physics, what role different genders fit in within physics, and all these through process are responsible in shaping the status of present physics. And we feel that women, though have already entered in physics, they are good for certain role within physics, and probably it is not a domain where some domains are restricted for them to try and experiment, but not all. Now, let me think, because I think maybe sometimes this data can make us as, I mean, particularly me as a women physicist working in India uncomfortable. So let me just show you the larger picture. Is this the problem for India alone? So I don't think so. So these are the pictures by taken from a book written by Angela Saini, and it is a very good read. This book is called The Patriarchs, How Men Came to Rule. And uh, in this book, Angela shows these two examples. The picture on your right talks, this is a picture, or it is a flyer about a prize which is recently revoked, very recently in Russia, and this prize is called Mother Heroine Prize. And basically, the prize is offered to women bearing more than 10 children. And for a long time, this was held on, but recently, in a crisis situation, this prize has been revoked for various different purposes. But while this picture exists, at the same time, there are other posters like "Join the Army, Be a Man" are also floated across. And at the same time, if you see the picture on the left, she describes that this is an example where scientists in archaeology have broken gender stereotype by means of science tools. So this is a very popular picture now brought in UC Davis in exhibition, and the picture shows how archaeological tools has helped to show that women were also hunters and not just gatherers or caretakers, even from the time of prehistoric era. So if you compare these pictures, what you could actually see is these are the examples which show or which depicts how women's or men's contribution and responsibilities are perceived in different or in challenging situations, even in today's world. So, I'm sorry for bringing these examples, but what I mean to say is gender sensitization research or any effort should not be should be can be seen as a correction or as something that helps us to correct some historical injustices, which is true, but that is not just all of it. It also equips institutions for future science endeavors and understand our origin in a better way. And that is why investing some time in the roots of why probably this need of gender sensitization has arrived from history should be given a little bit of time. Now, I know, I mean, you all might be interested to see more data. So this is another example that I would like to highlight. Now, the left side picture, probably you are aware. Mm. This is a picture which you typically get during Women's Day. It's shared as a WhatsApp forward, and unfortunately, it is always shared during Women's Day and not on the Science Day. The picture on the right side is in fact drawn by students who participated in a drawing competition very recently, and the theme of that drawing competition was women and science. But if you see if you see probably a few pictures, I'll just wait for a few seconds. You would see that there is a tendency of normalization of women as a multitasker, right? So, and a normalization of ideal women as somebody who can do all things simultaneously is very common, not just amongst adults, but also children see and therefore depict, or children perceive it and therefore depict a women scientist is something who can smartly balance many things in society as well as at the family level. So what we really lack is, if we are providing some support structure, we definitely need to know that these are the perceptions that are built about women who are anticipated to do best in both worlds according to the larger domain or larger societal spectrum. I would like to also bring some examples. I hope all of you are following, and sorry about a large thing of my talk is data driven, but I definitely I'm showing this because all of these are data that you see in some form or the other on regular basis. Now, these are some NCRT textbook review data. So the snap that you are seeing is NCRT physics textbook chapters. And in each chapter, who are the scientists, those are mentioned. Now, again, a disclaimer that NCRT during the early phase of textbook writing have done a splendid job in terms of gender auditing of high school level textbooks. They identified tokenization of women and many counters stereotypic images and gendered roles, and did a great amount of work in mitigating these. But let us see how this is dealt at a discourse level in science, particularly in physics and chemistry textbooks at college level, as I believe many of you are college level teachers and above undergraduate, and also dealing with UG and PG level students. So if you see NCRT physics textbook, for example, at 11, have zero mention of any female scientist. Let's see what happens to NCRT Physics 12th textbook. You would see even chapter wise, there are mentions of many scientists which happen to be identified as male. There's only one mention of Marie Curie in the textbook. Now, how is the scenario for chemistry? Well, not much different than what we see, other than no other mention other than Marie Curie, and none at for standard 12th. Now, this is like a metadata, which where we looked at particularly pictures as well as mentions of names of women and male scientists. Now, let us, meanwhile, when I showed you all these physics and chemistry textbook metadata pictures, let's think more critically about what I would like to take you to think more carefully about. So, given that there is historical underrepresentation of women in science, one may not be surprised, honestly, to see this, because one can always argue that physics textbooks or chemistry textbooks are just for, they are presenting facts or concepts. So inexorably, it can be linked to people who have actually, who are actually associated with that relevant work. Let us say buoyancy, and then maybe the name is picked. Let us say chemical kinematic, and the name is picked. So it just happened that the concepts are picked, and the choice of who have presented them is followed up. But however, presenting this book in this form tends to overlook at the historical barriers that have excluded women in physics. And many incidents of women contribution of physics, in fact, is now known to be being overlooked or attributed to something else. So one strategy which, unless the textbooks are, which will be rewritten eventually, but one strategy is, if you are thinking about making it content specific, you could also bring the ideas about like how some of these are connected to the modern day modern physics or modern topics in chemistry now, and their probably integration of some women physicists or chemists is a possibility. It is also a good idea to talk about the underrepresentation itself in your class. So it tells about, even by the within the nature of science, why probably talking about or how talking about underrepresentation make this issue more visible to all, and then a vigilance about it can be built over the time. Is this only the case in India? No, but there have been textbook analysis which are done. Now, in India, up to standard 12, there are specific boards like CBSE and IB or other state boards which have a prescribed curricula and a prescribed textbook, which is not the case for undergraduate level textbooks as far as many universities in India are concerned. So doing such type of meta-analysis for physics or chemistry textbooks at undergraduate level is a challenge, but many of the reference books are cuts across in many universities in United States. So I'm showing the data of United States, which is taken from a special collection of teaching physics teacher journal, and this collection was on sex, gender, and physics teaching. And you could see that women with again mixed with a particular race have a little bit of domination. So as you go more intersectional, you would see a very disproportional sort of representation even at undergraduate level or so. Now, is this just the problem of numbers? Now, I think I spoke enough about numbers and enough about underrepresentation. Let us think about, is gender diversity and inclusion is only about talking in relation to numbers? Certainly not. So there are occurrence of paternalistic languages in many of our textbooks, and also in our day-to-day language or day-to-day discourse in laboratories. For instance, you would see that the gender representation doesn't limit um, to the occurrence of number, but like if you see how in within modern chemistry, Antonino Lavoisier is described or is attributed as father of modern language. So there is similarly father of green chemistry attribution goes to Paul Anastasis. So what I'm trying all of you to think about is there is a patternistic language that reinforces traditional stereotypes, and many of the textbooks that we are referring has occurrence of these in some or the other form. Now, these are three examples that I picked up, but I think the idea is much clear because even we oftentimes are still in the era where we contribute or where we call something as like a mother discovery or a father venture in some certain domains. And we keep on hearing this in our day-to-day discourse as well. So why these issues are flagged? Because this provides an impression to students or science community member that all the science that they are seeing or all the discoveries that they are seeing are contributions of great people. Now, there is no offense who are contributing it, and I mean, undoubtedly, their contributions are remarkable. But what I'm trying to say is science, as in general, is seen more in as a collective activity or as a collective enterprise, and research prepares us to see this as a collective or collaborative venture, whereas the use of paternalistic language ends up that contribution to be as a reward to maybe a single person or as appears as a single person discovery. Now, just one or two last points, and I promise that I'll discuss something that you see more than problem. The last, but again very important, is the genderedness in language. Now we talked about data, we talked about paternalistic language. Now think about, are many of the terms that we are using in textbook or in lab discourse are gendered, right? Obviously, yes. And in fact, I think if you give a free leeway, you would find even more examples like this. But oftentimes we use these terms, particularly something like connectors in physics, or in like in hardware systems that we use. They're often linked to male and female connectors, and these are making references to in context with the sexual bodies. Now, hardware devices placed between two cable connectors are often and if you need to change a connector from one dimension to other, are referred as gender bender or gender changer. So these descriptions of the device or are again referring to our sexual bodies. And if we are trying to find a pair that doesn't fit in, it is also appears as this is not a correct match. So all of these, like all of these descriptions or discourses are leading towards seeing how these are sexualized, or how gendered language is very much part of our day-to-day conversation within physics labs, and they sound sexist or normative, particularly because they are just targeting to only two stereotypical type of gendered or sexual bodies, whereas alternative terms such as socket and plug can always be used. Ancillary or secondary boards can always be used as a part of discourse. Now, I brought this up because we often, like, no matter how many times we think about making things gender neutral or gender sensitive, we still keep on using them, not even in the textbook, but in our day-to-day lab discourse. And it is really something that we need to think thoroughly, and in our classroom norms as well as in our day-to-day norms in dealing with different lab groups who probably identify them beyond the regular or beyond the just two genders or two sexual bodies that we are familiar with, and a push towards using less gendered terms definitely makes space more comfortable for all, and things that everyone can contribute into science, because these are not the references made about the sexual bodies that they may not align their identities with. So I think I kind of like covered at least one example in many of these, but what I would like to do in next couple of minutes is, we talked about all of these examples as problem area, like what problem lies in terms of genderedness, in terms of language, in terms of textbook choice, in terms of policy, in terms of who is supposed to work about gender diversity. It is not my protocol, or it is not my job, and maybe let me be more proactive, or let me be active when only it comes as a institutional or as a government policy. But what I would like to do in next couple of minutes is to see, are there way forward for really seeing this problem, and how we on our own at individual level as well as at institutional level can see ourselves to be contributing successfully in some of these initiatives. Now, one example I would like to give here is come from again another activity that we do at school level. This is an activity of phases of moon, where it is a gender it is a role play of students where you act as sun, moon, and earth, and based on the rotation conditions set for for moon and earth around sun, uh, it helps us to identify different phases of moon. Now, this is a very routine activity that many of you probably have seen, have enacted, or have been trying at your school. Now, why this is interesting in terms of gender? Because many of our textbooks written in bilingual or in regional languages also translate this activity, but oftentimes, in this translation, genderedness of the term becomes a challenge. For instance, in English, um, son doesn't have a gender, and um, by tradition, it is typically referred as masculine in many cultures. It is considered as a masculine deity, whereas and moon is referred as feminine in some cultures and masculine in other. In Indian popular script, think moon. We often refer it as Chanda Mama, so probably closer to the male identity, whereas Earth is referred as Dharti Mata or Dharni, which is referring to the female identity. Now, what happens is when you are distributing such roles among student, unless we call for or we recommend a gender neutral policy in selection, there might it might look a trivial stance to see, but it might impact it because some young adults or children who doesn't want to define themselves yet to any particular gendered identity may deny to work, may deny to enact as any one of these character, or they may pick up a certain character just because they wanted to show their closeness to the attributes that are more masculine or more feminine in nature. On the other hand, if we keep many of these things that people do in science, just as mentioned in my previous examples of gender bender and other language related term, one can do a very local level corrective measures job in terms of making a gender neutral discourse in within the classroom. Sorry, I think I would take like 10 to 15 seconds break here, and I, based on what all we thought or what we all talked, I want all of you to think about and see if you could find some alternative for one or two of these terms. Now, this is again a fun activity to try out in school or in college or in classes that whatever you deal with. Ask your people to find out some terms from the website, like the first one I picked up from NASA website, but the others definitely have many examples which they would pick and see that they would like to change, because now they start seeing some sort of genderedness in the sentence that they are seeing. So see if you could, if you'd like to try maybe one or two and think of a better alternative. I may not have a ready answer for all, but you spending more time in disciplinary expertise that you have may come up with a better alternative to represent these. Feel free to pop up your answers if you would like in the comment box meanwhile. All right. I hope you had some fun and ideas about how some very peripheral but yet effective strategies can be worked out to think more carefully about genderedness in the discourse that that you have with your students. I would like to focus on a few more examples which now, many of you are teaching many on day-to-day basis and interacting with graduate students, with postgraduate students, or with college level students. And you come across students saying many of these things like they haven't sorted, or they don't know what yet their career choice is. We often come across them talking about explaining or attributing some sort of genderedness to within subdomains of discipline. An example that I always like to cite is a friend of mine during my master's course had given me an advice to pick up experimental physics over computational physics, because according to her, computational physics is more like a geeky type, and so you really need to stand out very differently or have all the nerdy or geeky way of thinking about computation. And whereas experimental physics is more ladylike science, or it is more disciplined in a way where you can plan, where you can develop a strategy, and that is somewhere maybe our comfort lies more. And there are many other examples which you might have come across. Now, what all these some of your pupil or peers talking about that they feel not much useful for the time of crisis for others, or they may have performed very well in the exam, but they just feel that I still probably must have done well only because the exam was set very easily. So there are many perceptions or many experiences that a lot students share, which kind of attributes to how they are thinking about themselves with respect to that discipline. Now, why all these examples have been brought up? Because oftentimes, if you are marginalized within a particular discipline, for instance, women in physics, a lot of times see that their success and failures are always tested at a different scale with respect to others, and this is something which is often prevalent, or which is often can be seen more dominantly in a marginalized group within that discipline. So, for instance, women a lot of times often think the parameters for success and failures differently for themselves and for others. They also, if they have done something very well in terms of their exam, or let us say they have received some scholarship in a very competitive program to participate for national level or international level PhD program in a very reputed university and department, they would feel that much of the contribution is not only of their grades, but it is also because of the connections that their mentors have. So a lot of times they don't want to give the credit to themselves, but they often would like to share that credit with many other situational things that they are in when it comes to success. But failure is entirely their own responsibility. And now, how all this is relevant to gender? Because, as I said, effects of imposter, feeling of imposter, affects the marginalized communities in a much more bigger or much more challenging way. There are articles, there are evidences and anecdotes which have shown that a lot of women decline or decline many offers for awards or many responsible position, thinking that it is more masculine in nature. So in spite of being capable of doing their jobs well, they just don't believe in themselves with the imposter, and with the marginalized communities within women. If the intersection is with a geographically distant area or language barrier, these effects stop up like anything, and the disproportionality is very much visible in domains of physics and mathematics. So why again this discussion is brought? Because there are data, there are evidences which have shown that unless that imposter or bias feeling within the discipline, which is very much the culture that we live in or we experience on day-to-day basis at workplaces, may self-limit their efforts or their opportunities. For instance, a lot of students may decline to go for particular positions. They may decline to try out new research area, try out new collaboration. They may isolate or disintegrate themselves from a group. And also importantly, they may not say no to the work or, offered to them, which may often ends up more managerial or administrative in nature, but may not give them enough limelight, which probably their counterparts within the same discipline may receive. Why we brought this up in the gender and diversity inclusion? Because I believe that many of you are in the ambassador level positions where you are the one who are you may not identify with that gender that I'm talking mostly about, but you are the one who are dealing with different genders within your discipline on day-to-day basis. So it is important as a mentor that you understand that these are challenges which are systemic in nature, which are cultural in nature, and very much rooted and very much lies even in today's world amongst our students. And it is very much our responsibility to ensure that whenever these challenging or critical situations occur where they start doubting themselves or their contribution, and you see a slightest hint that this is something that is a deserving student but is a situation of self-doubt, then you can, as a mentor, approach in mitigating the situations. Now, last but not the least, since many of you, I think, are people who are often data-driven, this is the last example that I would like to show. Again, unfortunately, this is an example in US context, but a very much in line with what probably NEP, some research efforts in NEP should be thought in towards. So this is like the data or the graph shows physics diversity. On the left shows it shows in terms of women representation in BSc and PhD level degrees. And on the right, it shows URM is underrepresented minorities. So you see the red and blue lines are indicating the percentage of PhD awards by awards of given to women bachelor's and PhD students in the spectrum of 20 years, and to the students of racial minorities within physics. And if you see, obviously there is, I mean, the dotted black line is the actual percentage of graduate age population of these students. And you would see that remarkably there is a great decline in terms of proportion of people who are picking up PhDs in physics, both in terms of women and both in terms of racial minorities. So if you think more carefully about like why this might have happened, again, we can look for the data through surveys, but one of the reasons that many the literature has recommended that this is happening because of access issue, that the students are not getting enough information about how they can get enrolled into PhD programs. Or another issue is they are self-selectingly opt out, thinking that they will never be able to make it. Now, both these are not very different situations that you would also see happening in Indian context, because the leaky pipeline effect has been talked about for years. So the problem or the concern that exists very much in other countries lies also within India. So to see why probably students are self-selectively opting out from the process. There was a survey done nationwide with the PhD departments in United States. And this survey was done almost to all active physics departments, and head of the physics department or admission authorities participated in it. Similarly, some questions of the survey were also given to potential graduate students, which are final year graduate students who are likely to appear for PhD programs. And we asked both stakes like faculty as well as students to rank various different admission criteria according to the importance. So how do the importance of each admission criteria on a scale of 1 to 10 lies from their perspective. And I promise this is the last data slide. So what this shows is each of these criteria, and you would see around 15 to 16 criteria, and each of these criteria was ranked on a scale of 1 to 7. And you would see the blue dots are referring to students and red dots are referring to faculty or departments. So if you notice, you would see that there is some commonality. That means some of the criteria were seen as equally important by both faculty as well as by student. But if you see like all the criterias and the difference between perception of what is felt important for a successful application for according to students group and according to faculty group, you would see the differences are like getting more and more clear. For the blue dotted lines indicate that there are many factors which students think way beyond important than teachers, which who are the one who are actually there at the level of selection. And in general, student has a tendency to think everything is important. Now, I think why this matters in terms of physics educators or someone like you, whom probably are into various professional services, which could also deal with admissions, and why or how this information can be utilized. So you would see that if there isn't a correct messaging about what is needed or what is actual selection criteria for that particular program, students may think that everything is everything is at the highest priority needed for getting into a PhD program. An example given can be prior publication. And in fact, PhD is a time where most of your publications would come out. But if a student think that prior publication is a mandatory or is almost like a non-negotiable requirement for PhD program, then somebody who may have great motivation and great ability to do good PhD would think that, well, I don't have yet a publication, and so I'm not maybe a great fit for applying for PhD. So self-selectively opting out from the process just based on the perceived information about what is felt important may harm in bringing actually only a certain pool of potential candidate for PhD program. And that is where probably gender sensitivity matters a lot, because these effects again are seen disproportionately amongst women candidates who probably would tend to apply to only familiar institutes or only after publication, just because they feel that all of these criteria needs to be mitigated in order for a successful application. And you as an ambassador probably can be an active or a vocal about what is really important in terms of admission. And This is not something like, I mean, the research studies are intensive, but this is something that also has an impact on policy. As a matter of fact, some of the research that I showed in the previous slide have resulted into thinking about reconsidering how the effect of GRE in terms of like who are the people who are doing fairly well in GRE, and many of the institutes which now have decided to drop out the GRE, at least subject GRE to in a great extent in many university as a mandatory or the only requirement for PhD program, and thought of going for more complex, more hybrid structure for reviewing PhD admissions or applications. So, last but not the least, so there can be several things that can be learned through research, but there are also several programmatic structure that one can invest in. Another program that I would like to mention is recently started by TIFR and Homi Bhabha Center for Science Education, is Vigyan Vidushi, which is a structured 3-week summer school for postgraduates, women, first year women physics students. And essentially this program orients them to think about future career choices that they would like to make. It is a great opportunity for them to think about or to meet people who are in the juncture of making these choices, and learn from their mentors, from their peer about application process, about possible work culture that they are getting into, and about the nature of PhD, so they can make various informed choices. So it is not that gender diversity and inclusion can be achieved only by talking something by changing a narrative that you see in the textbook, or a practice that you think an individual or a solo person can commit to. But institutions can also make foundational or programmatic efforts to deal with these in a more definite yet useful way. Last, I think many of us have been working in education area as a teacher or teacher educator for quite some time. And in a unprecedented time like COVID, when most of the world was moving to online, and which had a long-term effect that many of our programs, yet including the teacher professional development program, are yet happening in an online mode. We also need to think more carefully that even access to many of these online program may have some genderedness effect. Oftentimes, there are disproportionate access to many of the instruments, many of the data-related devices, and the data itself to women, and one cannot be just accounting that just probably easy go in the access in an online forum probably would provide a great solution uh, to deal with gender diversity to a great extent. So one needs to also be mindful about disproportionate access in terms of data, and find a way to mitigate it in case if many of these things happen in a offline or online mode, no matter what the modality is. But gender, as you could see, has an overall influence in how our educational policies are thinking in terms of like who are the people who would contribute into science now and in long run. But you as a people in the position of making this change has an upper hand to meaningfully contribute and operationalize many of the things in what national education policy actually talks about gender, and bring it to reality, in my opinion. So I think, yeah, with that, I would definitely love that our when we give this talk in couple of years down the line, we would like to see a more diverse picture than what maybe I showed you to begin with in when we started talking about gender diversity and inclusion. So thank you again, and I would definitely love to hear if there are any comments from any of you or any question. Thank you.
Okay, thanks very much for an excellent presentation. So any comments, questions, or if you even want to share some experiences or thoughts, you're welcome to do so.
Yeah, so, madam, I just want to share my one experience recently. Actually, we people have applied for this startup grant from UGC, and from our university, only three ladies were selected, and no gents was selected actually.
Mhm.
So that data is also there. Means this is one of the example.
Right. Thank
And
you, Think, for bringing it up. I don't know. Can I know the first name because
it's Surinder Pratap.
Yeah, so I guess, I mean, what I showed today is influenced by today's statistics about who is underrepresented in a particular discipline. But there are other disciplines where, so, and that is where maybe I picked up to talk about more women in physics. But having said that, I totally agree that whichever is an underrepresented minority in terms of gender definitely needs a greater intervention in terms of policy, and that is what national education policy also talks about. Unfortunately, as of today, science talks more about underrepresentation of women, and yeah, I guess as long as there is a equitable and fair participation of all, I think we definitely would. It will be an ideal world where we don't need to even think about like what gender we are representing in terms of these selection or choices of who are receiving the grants or um, uh, scholarships, etc. So thank you, Surender, for bringing up this.
Yeah, ma'am. So basically, your this presentation is moving towards means if in one sense you are saying that means females have been basically, I mean, sidelined. That's what I am able to understand from your this one in higher educations, right, ma'am?
Yeah, so that is like one
So
angle.
it is happening even in orthodox families as well. I mean, so they are giving more importance to their male children over females actually, and still it is happening actually, and there is no shame in accepting those things. Still, it is happening according to Indian mentality. I mean, in some families. So basically, that's why that is also. But yes, we cannot say 100%. So that is there. Yes. Thank you. Ma'am.
Right. So thank you for bringing it up. And yeah, as rightly said, so it is like policy wise, probably it may look very different or alien, but it is not. And a lot of these things are happening just as an implementation of what is the culture that we live in, right? On our day-to-day basis, not just as physicists, but also as a person in the society. Yes.
Deepa, are you aware of the results from this DST, which initiated this gender advancement for transforming institutions, Gati? A lot of ground data was collected, but I'm not
Yeah.
sure that they're in the public domain, or are you aware of? I mean, I know that whatever little I've known that women are underrepresented in almost every aspect of,
Right, right. So I
in these.
think, I mean, much of the Gati Charter, I mean, I haven't seen all the data, but I'm very much kind of like aware of Professor Pratibha Jolly has given several talks at HBCSE, at TIFR, and on also on other occasions like International Conference of Women in Physics, where she brought up uh, how some of these initiatives and are very useful, and many at the ground level or in the base level, many of the institutions have adopted to make to take this as a serious agenda. And I think many of the accreditation schemes are directly linked to that. So I think it definitely kind of like makes an indirect impact therefore on the institute accreditation. So that idea is greatly also appreciated. But yeah, I think there is a lot more work, as Pratibha herself mentions, that can be taken up to at more national level universities and institutes, and not probably just at very research intense institutes and universities. And that is where I thought maybe much of our audience today can be brought up and can take this forward in their own respective institutes.
Thank you very much, Professor Deepa Chari, and thanks very much to all of you for being there this evening.